What do generator, rotor, and stator components do? Imagine a machine that turns mechanical energy into electricity. This is what a power generator does. Inside, two main parts work together to make this happen. These are the rotor and the stator. They are the heart of most power systems, whether in traditional power plants or renewable energy setups like wind turbines. Understanding how they work helps us see how electricity is made and transmitted across our grids. The stator is the stationary part of the generator. It is usually made from a core of laminated electrical steel, which helps guide magnetic fields efficiently. Wrapped around this core are coils of copper or aluminum wire called windings. When the generator operates, the stator either produces a magnetic field or receives one, depending on the design. In most cases, the stator contains the armature windings where the voltage is induced. As the magnetic field interacts with these windings, it generates electrical energy that flows out to power homes, factories, and cities. The stator must handle high voltages and often has cooling systems to prevent overheating during continuous operation. Its design ensures that the magnetic flux flows smoothly, maximizing electrical output. The rotor is the part that spins inside the stator. It is mounted on a shaft connected to a prime mover, like a turbine or engine. The rotor carries either electromagnets or permanent magnets. When it spins, it creates a rotating magnetic field. This rotation is what causes the magnetic field to change relative to the stator windings. This change in magnetic flux induces a voltage in the stator windings, following the principle called electromagnetic induction. In direct current generators, the rotor has armature windings and uses a device called a commutator to produce steady direct current. In alternating current generators, the rotor usually has field windings energized by direct current, which creates the magnetic field needed for continuous power generation. The rotor must be built to withstand mechanical stresses from spinning at high speeds, sometimes over thousands of revolutions per minute. Together, the rotor and stator form a system where magnetic fields and conductors interact. As the rotor spins, the magnetic field it creates cuts through the stator windings, generating an electric current. This process follows Faraday's law of electromagnetic induction, which states that a changing magnetic field induces voltage in a conductor. The efficiency of this process depends on the materials used and how well the components are designed. In power systems, these parts are built to last, minimizing energy losses and ensuring reliable operation. They are essential in all kinds of power generation, from large fossil fuel plants to wind turbines and even small industrial generators. Without these components working perfectly, the flow of electricity that powers our daily lives would not be possible.